Hello student, in the last video we already discussed nomenclature of alcohol and phenol. Now we will move with nomenclature of ethers. First compound CH3OCH3. Here in a first compound, for its a common name, 2-methyl group is present, hence it become dimethyl, and oxygen it tends to ether. So its a final common name is dimethyl ether. If we are talking about its IUPAC name, then simple trick is there that we have to remember alkoxy-alkane, in which oxygen is moved towards less number of alkyl group. So for CH3OCH3, its IUPAC name is methoxy. OCH3 means methoxy, and for a CH3 it become one carbon, hence it become methane. So final answer of CH3OCH3 is methoxymethane. Second compound CH3OCH2CH3. In second compound, for its a common name, focus on the left side of oxygen, methyl group is present. On the right side of oxygen, ethyl group is present, in which ethyl comes first in alphabet. Hence, the final common name for second compound is ethyl methyl ether. If we are talking about IUPAC name of a second compound, then oxygen is moved towards the left side because it contains one carbon, hence it become methoxy, and for a two carbon it become ethane. So final common name is methoxy ethane. Third compound CH3CH2O CH2CH3. Here both side of oxygen ethyl group is present, hence its a common name is diethyl ether. If we are talking about IUPAC name of a third compound, hence oxygen is moved towards any one side and it become ethoxy, and still two carbon is there, hence it become ethane. So final IUPAC name of a third compound is ethoxy ethane. Fourth compound CH3O CH2CH2CH3. Here on the left side of oxygen methyl group is present, and on the right side of oxygen propyl group is present. If we are talking about its a common name, as I said earlier, if three or more than three carbon atom is there and it become linear, so we are putting n tends to normal. So the final common name of a fourth compound is methyl and propyl ether. Once again it become methyl and propyl ether. Here n tends to normal. If we are talking about its IUPAC name, then according to IUPAC rules, if three carbon is there, then we have to give the number. Here OCH3 group is a present on a first carbon, hence it become one methoxy, and total three carbon is there in a long chain, hence it become propane. So final IUPAC name of a fourth compound is 1 methoxy propane. Fifth compound CH3O CH3 twice. Here if we are talking about its a common name, then according to rules of a common name, CH3 is in a together form, so we are using iso for that. Total three carbon is there, hence it become isopropyl. On the left side of oxygen methyl group is there, and on the right side of oxygen isopropyl group is present. So the final common name of a fifth compound is isopropyl methyl ether. If we are talking about its IUPAC name, then long chain that contain three carbon, on which second carbon contain methoxy group, means OCH3 group is a present on a second carbon, so that its a final IUPAC name is 2-methoxy propane. If we are talking about sixth compound, it becomes C6H5OCH3. Here C6H5 means phenyl. On the left side of oxygen phenyl group is present, on the right side of oxygen methyl group is present, in which methyl comes first in alphabet, hence its common name is methyl phenyl ether. It is also known as anisole. This question is already asked in Gujket exam. If we are talking about its IUPAC name, then OCH3 means methoxy, and the C6H5 means benzene. So its a IUPAC name is methoxybenzene. Seventh compound C6H5O CH2CH3. On the left side of oxygen, phenyl group is present. On the right side of oxygen, ethyl group is present, in which ethyl comes first in alphabetical order. So its a common name is ethyl phenyl ether, which is also known as a phenol. This question is also asked in board exam. If we are talking about its IUPAC name, then C6H5 means benzene ring, which contain OCH2CH3. Here OCH2CH3 means ethoxy group, means benzene ring contain ethoxy group. Hence its IUPAC name is ethoxybenzene. Compound number 8, C6H5O C6H5. Here diphenyl group is present on either side of oxygen, hence it become diphenyl ether. If we are talking about its IUPAC name, then C6H5O tends to phenoxy and C6H5 tends to benzene. So its IUPAC name is phenoxy benzene. Compound number 9, CH3CHOH CH2CH2O CH2CH3. Here in a ninth compound, two functional group is present, OH and ether, in which reactivity of oxygen is a more than ether compound, sorry, reactivity of alcohol, reactivity of OH group, not alcohol, reactivity of OH group is a more than ether, hence we are giving the number in a such a way that OH getting less number. Here for ninth compound common name is not possible, so we are directly focusing on its IUPAC name. Here fourth compound contain ethoxy group, hence it become 4 ethoxy. Now total 4 carbon is there in a long chain, hence it become butane, and on a second carbon OH group is present, hence it become all. So final IUPAC name of a ninth compound is 4-ethoxybutane 2-ol. Question number, sorry, compound number 10, cyclohexane, on which first carbon contain 2 methyl group and on a second carbon OCH2CH3 is there. Here first thing that how to give the number. So if we are focusing on a first carbon, 2 sub branches are there, and if we are talking about second carbon, then only one branches is there. So we are giving the number to the such carbon atom which possess more number of branches. So carbon 1 that possess 2 branch, hence it become the first one, and the second carbon OCH2CH3. Here second number carbon which contain ethoxy group, while first number carbon contain dimethyl group. So its a final IUPAC name is 2-ethoxy 1,1-diethyl, sorry, 1,1-dimethyl cyclohexane. Once again I am correcting, 2-ethoxy 1,1-dimethyl cyclohexane. And the last compound ClCH2CHCH2O. Here cyclic compound is there, in which cyclic structure is formed between carbon 1, carbon 2 and oxygen, hence it become epoxy, and that epoxy is present between first and second carbon, hence it become 1,2 epoxy. On a third carbon chlorine group is present, hence it become 3 chloro. So final IUPAC name of a last compound is 3 chloro 1,2 epoxy propane. Remember one thing, here epoxy is used for a cyclic compound in which the cyclic structure is formed between carbon and oxygen. Here that structure is formed between first and second carbon, hence it become 1,2 epoxy. So it is 3 chloro 1,2 epoxy propane. One more thing that already asked from this topic in a board exam, that identify symmetrical or simple or a mixed or unsymmetrical compound. So here compound first, compound third and compound 8 are symmetrically ether. Simply we have to remember, for first compound, for third compound and for eighth compound both the side same group is present, hence it becomes symmetrical. While if you are talking about remaining compound, then either side of oxygen, means both side of oxygen is satisfied by different group, hence remaining are the example of a mixed or asymmetrical or unsymmetrically ether compound. Once again, first compound, third compound and eighth compound are symmetrical ether, while remaining are example of asymmetrical ether compound. And the sixth and the seventh compound is already asked in a board or Gujcat exam, that is structure of anisole and the structure of phenitol. Now we will discuss electronic structure of alcohol. Here, to understand electronic structure of alcohol, we used methanol, that is CH3OH. Here, one sp3 hybridized orbital of a carbon that overlap with one sp3 hybridized orbital of oxygen and it form sigma bond, or we can say single bond. Now remaining three sp3 hybridized orbital of a carbon that form sigma bond with 1s orbital of hydrogen. Here, after the formation of a sigma bond between carbon and oxygen, oxygen is formed one more sigma bond with 1s orbital of hydrogen atom. So oxygen form two sigma bond, first one with sp3 hybridized orbital of carbon and the second with 1s orbital of hydrogen. Now still oxygen atom contain two lone pair of electron in which repulsion is a take place between that two lone pair of electron, and because of that repulsion its a real bond angle is a 108.9 degree instead of 109 degree 28 minute. Whenever sigma bond is present, or we can say whenever sp3 hybridization is take place, at that time the value of bond angle is 109 degree 28 minute, but due to presence of a two lone pair of electron on oxygen, they possess repulsion, and due to this COH bond angle is a decrease from 109 degree 28 minute to 108.9 degree. Now electronic structure of phenol. Here CO bond is formed by overlapping of one sp3 hybridized orbital of oxygen and sp2 hybridized orbital of carbon. Once again, here CO bond is formed by using sp3 hybridized orbital of oxygen, while sp2 hybridized orbital of carbon, because carbon that present in a benzene ring which become double bonded. So oxygen utilize their sp3 hybridized orbital, while carbon is utilize its sp2 hybridized orbital. After the formation of bond between C and O, oxygen form one more sigma bond by using its 1sp3 hybridized orbital that overlap with 1s orbital of hydrogen. Still, oxygen possesses two lone pair of electron. Here, CO bond length is less in case of phenol as compared to methanol. Here, two reasons are there. The first reason, that oxygen is a more electronegative while carbon is a less electronegative, hence partial bond is formed between carbon and oxygen. Because of this reason the bond length is a decrease. And the second reason, the hybridization of carbon is sp2. Maybe they are asked in a question why the bond length of a CO in a methanol is longer, or we can say more than CO bond length in phenol. So simple remember two different point. The first point, that here partial double bond is present between carbon and oxygen atom, and the second reason, that hybridization of a carbon is sp2, while in case of methanol hybridization is sp3 and no any kind of double bond, partially double bond is present. Because of this, simply we can say that the CO bond length in a phenol is smaller than CO bond length of methanol. Electronic structure of ether. To understand electronic structure of ether, let's take an example of dimethyl ether, means CH3O CH3. That is its common name, and its IUPAC name, as you know, methoxymethane. Here oxygen possesses 4 sp3 hybrid orbital, in which 2 sp3 hybrid orbital is a form sigma bond with sp3 hybridized orbital of carbon, or we can say alkyl group. Now, due to presence of CH3 group, due to presence of two CH3 group, they possess repulsive interaction. Here methyl group is electron donating group, hence two electron donating group is present near to oxygen, so that repulsion is take place between two methyl group. Because of this, its bond angle is 111.7 degree. Most important thing that you must remember, whenever sp3 hybridization is take place, at that time the value of a bond angle is 109 degree 28 minute, but in case of ether it become 111.7 degree. And simple reason is there, that a repulsive interaction present between two methyl group. So we studied electronic structure of alcohol, phenol and ether, in which if we are talking about bond angle of methanol, then it become less than 109 degree 28. If we are talking about phenol, then it become 109 degree. And especially if we focus on electronic structure of ether, then the value of COC bond angle is 111.7 degree instead of 109 degree 28 minute. All these three structure that you have to remember with their values, as well as values of bond angle, as well as value of its bond length. And also you have to remember this thing for theory, 2 mark theory also.